In this video we're going to look at differential equations and just some things to be careful of and to look for as we move ahead. But first of all, we have a slope field. The slope field is the field for one of those differential equations. Please figure out which one and then go to the quiz section and take the quiz labeled with the date and slope fields. So pause here and figure out which one it is. Now, we've talked about separable differential equations before, but I just wanted to mention, and I don't want to solve all of these, I just want to kind of get you a start, but I don't want you to ever be thrown by the use of other variables. And I know we talk about in Calc 1 that if what you're taking the derivative of is, if it's d, and I put this box here because it doesn't matter, it doesn't have to be dy dx or dy dt or whatever, but whatever you're taking the variable of, or the derivative of here, if that appears over here, our only method is separable differential equations. Okay, so down here, y prime, now I did this purposely, but I don't like to ever have y prime. I like to have dy dx. Okay, especially for a separable differential equation. So dy, y is in the differential equation over here. So I'm going to have to do separate, integrate, and solve for y. So when I do that, I multiply both sides by dx. I divide both sides by y. So I have 1 over y dy equals 7x dx. And then I integrate, and of course I get, put this over here, the natural log of y equals 7x plus a constant. Well, to get rid of the natural log of y, I take e to both sides. So it becomes y equals, now this is something that always trips people up. Remember, this, e to the 7x plus c, is the same as e to the 7x multiplied by e to a constant. Because when we're multiplying the bases, we add their exponents. Well, e to a constant is simply another constant. So I can just rewrite this as y equals a constant multiplied by e to the 7x. And then, of course, if you were given some initial condition, like at x equals 2, y equals 7, you could solve for the constant. Okay. Now, this other one, again, you'll see that the piece here appears in the differential equation, so we need to use separable again. So I'd multiply both sides by dl. dl. I divide both sides by p. Okay, I would leave the numbers where they were. Okay, so you've got 1 over p dp equals 2 over l dl, and you'd integrate. So you'd get the natural log of p equals 2 natural log of l plus c, and I'm going to let you take it from there. Okay, I rely on the fact that you could finish it, although it might be beneficial to just mention you should make this L squared. Use your log rules. You don't like to have a coefficient on a log. Okay, this is a problem from a few years ago on the AP exam, and again, it threw people quite a bit because it had a dB dt, and then b appeared in here, and they didn't initially know they were going to need the differential. The separable differential equation. So it's a baby bird gaining weight at a proportional to the difference between its adult weight and current weight. So essentially, in this case, the change in the bird's weight is a function of the bird's weight, and that's why it's how the bird is changing with respect to time, but that's a function of the bird's weight. So that's why it looks the way it does. Is it gaining weight faster at 40 or 70? Well, of course, we just plug 40 in. So 1/5 of 60 is 12. Let me just make a little note here. It's 12, and it'd be, grams per day, I suppose. G per day. And when we plug in 70, we get 1/5 of 30, which is 6 grams per day. So it's gaining weight faster at 40 grams, and you could explain that. Next, it said find the derivative, or the second derivative, excuse me. This is notation for second derivative. When this problem was on, I thought it was easier to multiply the 1/5 through. 1/5, get rid of the parentheses, so we had 20 minus 1/5 b, because then the derivative of this, well, of course the derivative of 20 is gone, and the derivative of 1/5 b is very easy. The one thing to be careful of is because it's with respect to t, it's a related rate. It's how b is changing with respect to time when time is not the variable. Okay, think about that for a second. It's how b is changing with respect to t, but t is not the variable. That's a related rate. So, you think, okay, well, the second derivative, again, the derivative of 20 is gone. The derivative of negative 1/5 b is negative 1/5 d. Oop, fit all the letters in here correctly. dB dt. And we know what dB dt is. It was given to us in the, that is right here. So we substituted it. We said, well, it's going to be negative 1/5 of 1/5 100 minus b. So if we multiply this through, it becomes negative 1/25 100 minus b. And it says, why it can't be this graph. Well, you'll notice that there's a change in concavity right here. It's concave up, and then it becomes concave down. Well, that isn't reflected here. This is negative. And since it looks like we'll never reach 100, we're always multiplying a negative by a positive. It should always be concave up. Okay, so I'm not going to, this reflects that it should always be concave up, and it's not. You could write that, more wordy than I could, or you should. But let me get to part C. Use separation of variables. It was nice of them to say that. They normally don't. But use separation of variables to get the equation. So we had no choice here but to divide by 100 minus b. Right here we divided by 100 minus b, and we multiplied by dt. So let me just work it right over here. We're going to have 1 over 100 minus b dB equals 1/5 dt. Alright, make sure you see that. Then we do the antiderivative. Well, this right side is easy. It's just 1/5 t plus a constant. This other side tripped people up because they all looked and they said, well, it's just natural log of 100 minus b. You're very close. But let's write that down for a second. Let's write natural log of 100 minus b, like that. Let's think about the derivative of this. The derivative of this would be 1 over 100 minus b multiplied by the derivative of 100 minus b, which is negative 1. But it's not negative up here, it's positive. So we need a negative out front. A lot of people miss that. From there, how I would handle this is change the signs on every term. So it becomes natural log of 100 minus b equals negative 1/5 t. And a constant is a constant, so you can leave that as plus c. Then you took e to both sides, like this. So you had 100 minus b equals, a constant, e to the negative 1/5 t. Then you could subtract 100. And then you could change the signs again because of that negative b. you should have a positive b equals negative to negative 1/5 t plus 100. And then you could use the point, plug in 0 for t right here, and set b equal to 20, and you can solve. I believe it came out to be 80.